Hi, I'm Ethan, Infrastructure Advocate at Portainer. In this video, I'm going to show you how to deploy a Docker stack using Portainer. If you're managing multiple containers that work together, like a WordPress site and its database, deploying them individually is a complete pain. You're copying configs, managing dependencies, hoping nothing breaks. Docker Stacks, on the other hand, lets you define and deploy entire multi-container applications with a single compose file. And Portainer makes this dead simple. Today, we'll walk through deploying a WordPress stack using Portainer's web editor. I'll walk you through defining services, configuring environment variables 3 different ways, and setting up volume mappings for persistent storage. Link to the compose file is in the description so that you can follow along. Let's dive in. Before we jump into Portainer, let's take a quick look at the official documentation. The link to this is in the description below. Starting at portainer.io, I'll navigate to the documentation section. Then go to Docker under Using Portainer, select Stacks, and click Add a new stack. Portainer gives us 4 different methods for deploying stacks: the web editor, file upload, Git repository integration, and custom templates. For this tutorial, we're going to be using the web editor method. This lets us define our services directly in Portainer using Docker Compose format. Now let's head over to Portainer and get logged in. Here's my Portainer instance. I've got my local environment listed up top. I'm going to click into that environment now. Once we're inside, check out the navigation window on the left side. The third option down is stacks. That's where we need to go. I'll click on that now. I've got 1 stack deployed at the moment, Portainer itself, but we're about to add more. Let's click Add Stack in the top right corner to get started. Here we are at the stack creation page. We're sticking with the web editor in this demo. First up, let's give our stack a name. I'm going to call it WordPress just to keep it simple. Here are the same 4 deployment methods we looked at in the documentation: web editor, upload, repository, and custom template. Now in the web editor, let's paste our Docker Compose file. I've got that ready to go, but first let's walk through what's actually happening. I'll highlight the parts you'll probably want to customize for your own setup. Version 3 tells Docker which compose format we're using. Version 3 works everywhere, so unless you've got a specific reason to change it, we'll leave it. Services is where we define our containers. Each service becomes its own container. DB is the name of our database service. WordPress will use this name to find the database on the Docker network. Image, we're pulling MySQL version 8.1 from Docker Hub. This is the actual database software. Volumes, now this is crucial. DB_data maps our named volume where MySQL stores all its data. Without this, you'll lose everything when the container restarts, so don't skip the volumes. Restart always. If the container crashes or your server reboots, Docker automatically restarts it. It's pretty handy. Environment. These variables configure MySQL on startup. MySQL root password sets the root password. Notice we're using a variable here from our env file. MySQL database. WordPress creates the database automatically. MySQL user and MySQL password create the user WordPress will use to connect. The health check monitors whether the database is actually ready. The test command pings MySQL to see if it's responding. Timeout 20 seconds gives us 20 seconds per check. Retries 10 ensures WordPress doesn't give up if the database isn't ready yet. It'll keep trying up to 10 times before failing. Let's take a look at the next service, WordPress. This is our actual WordPress application. Image WordPress PHP 8.2. WordPress with PHP 8.2 included. Depends on. Now this is key. We're telling Docker that WordPress depends on the database, and specifically with condition service healthy. We're saying don't start WordPress until the database passes its health check. This prevents connection errors on startup. Ports 8080:80 maps port 8080 on your host to port 80 on the inside of the container. So you'll access WordPress at your local host, port 8080. Change that first port number if 8080 is already in use on your system. Restart always is the same as before. It auto restarts on container crash or reboot. Volumes, WordPress data persists all your WordPress files, uploads, themes, plugins, and everything. Without this, you'll lose all your content on restart, so don't forget it. Environment. WordPress DB host, DB3306, tells WordPress where to find the database. DB is the service name. Docker handles the DNS automatically. Port 3306 is MySQL's default. WordPress DB user and WordPress DB password need to match what we set in the database service. Health check. We're going to use curl to check if WordPress is responding on its web port. Interval 1 minute and 30 seconds checks every 90 seconds. Timeout 10 seconds gives each check 10 seconds and retries 3 times before marking it unhealthy. Volumes. This declares the named volumes we referenced above, DB data and WordPress data. Docker manages where these actually live on disk. You don't need to worry about the path. All right, let's paste this into the web editor. Now let's talk about environment variables again. First thing to notice, in this compose file, I'm using environment variable placeholders like MySQL database password and WordPress DB password. You might be tempted to just hardcode your passwords directly in here. Don't do that. Hardcoding secrets in your compose file is a security risk, especially if you're committing this to version control. So how do we actually set these values? Portainer gives you a couple of options. If you scroll down here, you'll see the environment variables section. Option 1, you can manually add each variable using the Add Environment Variable button. Just type in your key value pairs and Portainer will substitute those into the environment variable placeholders when it deploys. Option 2, if you've already got an env file with all of your variables defined, you can click Load Variables from env file. Portainer will read your file and auto-populate all of those fields for you, way faster if you've got loads of variables. There's also a third option that's completely separate from Portainer's UI. In your compose file itself, you can add the env_file directive with the absolute path to an env file on your server. This tells Docker to read that file directly. For this demo, I'm going to be using option 1. I'll just add the variables manually in the UI to keep it simple. But now you know all 3 ways to handle this. Now in this compose file, we're using named volumes. Docker manages those automatically, which keeps things simple. But what if you need direct access to your container files from your host system? Maybe you want to edit WordPress themes directly, back up your database files, or share content between your host and containers. This is where you'd use bind mounts instead. Here's what the same compose file would look like using bind mounts. Check out the differences in the volumes section. For the database, opt WordPress MySQL :var lib MySQL, host path on the left, container path on the right, separated by a colon. For WordPress, opt WordPress HTML :var www HTML. It's the same pattern. With bind mounts, those files live directly on your host file system at opt WordPress MySQL and opt WordPress HTML. You can browse them, edit them, back them up, total control. One important thing, make sure those directories exist on your host before you deploy. If they don't, Docker will create them, but they will be owned by root. This can cause permissions headaches later. So, named volumes when you want Docker to handle storage, bind mounts when you need direct host access. Pick whichever option fits your workflow. Okay, let's head back to the stack deployment in Portainer. Let's say we want to use an env file instead. I'll clear out these manually entered variables first. Now I'll click Load Variables from env file, and we'll select my file, in this case wp-stack.env. And there we go. Portainer automatically loads those variables into the UI for us. All right, before we deploy, let's look at the last couple options here. You'll see a webhooks toggle if you want to enable automated redeployments. I'm going to leave that disabled for now since it's optional. The registry section lets you connect to container registries beyond Docker Hub. This is where you configure access to private registries like your company's internal registry or other public registries like GitHub Container Registry or AWS ECR. And down here we have access control settings. By default, this stack will be restricted to administrators only. If you have a team environment with different roles set up, you can click Restricted to define more granular permissions. For this demo, I'm going to leave it at default. Everything looks good. Let's deploy the stack. Boom! Stack deployed successfully. That was fast. Let me click into the WordPress stack so we can see what was created. All right, the database container is up and healthy. WordPress is still starting up. Let's give it a few more seconds to finish initializing. Let's refresh the browser. Okay, great. It's healthy and running on port 8080 of the host machine. Now let's verify that WordPress is actually accessible. I'll enter my lab server's IP address and port 8080 since I'm calling a remote Docker host, not localhost. Perfect. There's the WordPress installation screen. We're live. And there you go. multi-container WordPress stack deployed in just a few minutes. We walked through the Docker Compose file, configured environment variables 3 different ways, covered named volumes versus bind mounts, and got everything running with a single click. The Compose file we use is linked in the description. Grab that if you'd like to follow along and try this yourself. If you've got any questions or run into any issues, drop a comment below. Thanks for watching, and I'll see you in the next one.